Hi Uma, how are you?
Yeah, hi sir. I'm good. Thanks for asking. I hope you're doing good.
Yeah, I'm fantastic. I'm doing fantastic. Thanks for asking again. Yeah. Okay, so yeah, I'm going to take a mock interview for network engineer role. Okay, so since you have a 2+ years of experience, right? So you have completed your CCNA training successfully. You have completed internship here, right? So this interview is all about scenario-based questions and how you will. I will check your skill set conceptual way. Do you have a proper concepts or not? And packet level also I will ask you. Okay, troubleshooting wise also I will ask you. Okay, are you ready now?
Yes, sir. I'm ready.
Yeah, I know you are ready for a long time, but sorry for the delay.
Yeah.
Yeah,
Okay, no
yeah,
problem.
yeah. Okay, so yeah, so could you please introduce yourself and what is your roles and responsibilities currently in your organization? Yeah, please go ahead, ma.
Okay. First, thanks for giving this opportunity to explain about myself. My name is Umaishwari Kunapareddy. I have 2 years of experience in networking operations, and I currently working in TCS as a network engineer. And currently I'm working for the Chroma project. Initially, I worked in digital infrastructure services. At that time, they give me a training in CCNA and networking technologies, and later I got a project Chroma, and in this project they moved me to this project. Here we are used to work on Cisco 1K devices and 9300 L3 devices, and here we are used to work on any kind of hardware level issues and protocol level issues. In case of any hardware level issues, I use it to engage with that particular respective tag team, and in case of any hardware level failures like fan tray or any power supplies, then I use it to create a RMA with that particular vendor team. And coming to protocol level issues, in case of any BGP flapping or any links goes flapping or any ISP flaps, I use it to get a ticket. So at that time, I will check our internal end. Then after, I use it to create a ticket with that particular vendor team like Tata or Airtel or AT&T. And other than this ticket handling, and I use it to do iOS upgradations, and we use it to do this iOS upgradation and this kind of activities in maintenance mode. Like we use it to work on this kind of activities, and we will schedule a maintenance window, and for doing these activities we will follow the MOP. And other than this, I use it to do the documentation for everything. Initially we have a MOP, but if in case we need to add or delete at the time of doing any iOS, then I use it to do each and everything in documentation, and I will submit this all documentation for my senior approvals. Then yeah, this is all I'm doing currently. Actively I'm participating this all activities. Yeah, this is all my roles and responsibilities.
Yeah, that's a fantastic explanation and very clear what exactly you're doing.
Thank
Awesome. Yeah, I have interviewed so many people, but this is a very good clear explanation about your roles and responsibility. Good. And yeah,
thank
let's check about your networking fundamentals. Okay. So
Okay,
suppose let me share my screen quickly. Okay. Yeah.
okay, sure.
If you see my screen right here, yeah.
Yes.
Suppose this is a switch. Okay. Are you seeing right? This is a
Yes.
switch. So
Mm,
PC1 is connected to PC2, and PC1
mm,
IP address is 1.1 and PC2 IP address is
mm,
1.2. Okay,
mm,
and PC1
mm,
MAC address is AA. Just consider PCP MAC address, PC2 MAC address BB. If I
mm,
initiate
mm,
a ping
mm,
to 1.2,
mm,
so
mm,
how exactly the ping works at the back end, what routing protocol, what layer 3 protocol it will use, and
mm,
just
mm,
these two these are connected to the switch, and explain me the ping
mm.
process step by step. Understood the topology?
Okay. Yes, yes, I got it.
You got it right?
Yeah.
Yeah, please
Yes.
go ahead. Yeah,
Okay, in PC1, if you're going to actually, why we using ping, right? For checking the reachability,
yeah,
the device is reaching or not, and we are able to check the latency. How it will check the latency? We will use the round trip time. So first, we are going to initiate ping in PC1. Like there is a IP address like 192.168.1.2 in PC1. It will generate a ICMP echo request. So it will contain in layer 3, there is a protocol number inside that layer 3 in header. So based on this ICMP echo protocol, it will understand this is ICMP protocol. So first it will initiate that ICMP echo request. In this that ICMP echo contain the type 8 and code 0. It means it's a echo request. So once it reaches that switch, and it will do that based on we all, it's not a first time ping, so it will not it able to understand the MAC destination MAC address. So based on that it will reach that PCB. So
So it's a
once it
first
is
time ping. It's a first time I'm pinging. Yeah.
okay, first time, it's a first time pinging means it will be in error. It will in buffer state, because if you're going to ping from first time, we don't know the MAC address, destination MAC address. So at that time, the ARP request will generated by the PC1. So
Very good.
inside the ARP, so inside that ARP request, that ARP will maintain the ARP table. So inside that we have a fields like a source IP. Source IP is nothing but that PC1 IP address, and the source MAC address. Source MAC address is nothing but the PC MAC address, and the destination IP. That is a target IP. So sorry, actually in ARP we will use the commands like sender IP and the sender MAC, and the target IP and target MAC. The target IP address is the destination. Target IP is the destination PC IP, and that the target MAC we don't know. So for identifying this target MAC address, that PC1 is generating this ARP. So once this particular packet, this ARP request is reached to the switch will check the destination MAC. At first it will check that sender MAC. So the sender MAC address is the PC1 MAC address, and it will check the destination MAC address. We don't know the destination MAC address, so it will not contain any destination MAC details. So at that
What is
time
the
that
destination MAC
switch
here in our request
act-
packet? What is the destination
in
MAC?
actually destination MAC address we are able to see that is a PCB MAC.
How
I
come
mean,
you will see? It's a ARP request, right?
okay. At that time, that the PC, and it will do the AND operation between the source
Not
IP
under
and the source.
operation. That is different. You're
Mm-mm,
generating a ARP request for the destination. So in ARP
mm-mm,
request packet, you said sender IP address is source IP, sender MAC address
mm,
is source MAC. What
mm.
destination IP is the whatever we are pinging,
Yes,
and
yes.
what is the destination MAC address here?
Uh,
Target MAC, you
Destination.
mean? What is the
Yes.
target MAC?
We don't know the target MAC address. For identifying the target MAC address, we are generating this ARP request.
Yes,
So
in the ARP
it
request
will do the
only.
broad.
Yeah,
Yes.
yeah. Now you're right.
It will, yes, I'm going to explain the
Yeah,
thing.
yeah.
So first it will do the AND operation between the source IP
Mm.
and destination subnet. Source subnet mask, destination IP, and the destination subnet mask. If the both results are same, then it will generate the broadcast packet to the PCB.
Okay,
Switch will do the broadcast, and based on this AND operation, it will go to the BCP. So based on the same subnet, the
got
both
it.
result will be same subnet. It will go to the PCB. If the both the results will be different, it will go to the gateway. So it will that once which receive this packet, it will do the broadcast, because we don't know the destination MAC address, right? So it will do the broadcast. So based on the subnet mask, that PCB we are connected that PCB also to the switch, so it will receive that packet, and it will check that the destination IP address, the target IP, it's a PCB owns a PCB own IP address. So it will reply back with the ARP reply. It will generate, it will give the information about its MAC address. So once it is received the switch, the at that time it able to know that target MAC and target sender MAC. So at that time it will do unicast to that our PC1.
So
So it
before
will
sorry
identify
to
the MAC.
interrupt you.
Yes.
Before generating ARP request packet to the switch, does
Mm,
switch will do anything? Sorry, does
it will
PCB will do anything?
before generating. Sorry.
ARP reply packet to the switch. PCB will
Uh,
generate a ARP reply, right? Upon receiving
yes.
ARP request. So before
Mm,
generating and sending back to switch, right? That ARP reply packet. What
mm.
computer PC2 will do?
uh, PC2 will check that that destination MAC, that table, right? That ARP table.
What ARP table? ARP table it will check or it will populate it,
It will populate.
right? It will
Mm.
learn the source IP and so
Yeah,
so
source IP and destination IP. What is the source IP? That is the PC1 source IP, and destination my IP is its
why
own IP
destination?
address.
Destination IP it's in own IP, so it
Mm,
will learn the source
mm,
IP along with the MAC address of source IP.
mm,
So what ARP contains, it will populate the ARP table. It contains the IP address and the MAC address for the respective IP. Okay. Yeah, fine.
Oh,
Now
mm,
go
mm.
slowly. Okay, you're saying everything perfectly. Just decrease little bit speed. Okay. Yeah.
Okay.
Now replay packet go to the switch. Now what exactly will happen?
Now here we know, I mean, switch able to, I mean, switch able to know the destination MAC here, so it will send that ARP reply packet to the PCA through unicast, because we already know that destination MAC and I mean
Good.
target MAC and central MAC address. So once that PC1 is learned that MAC address, then the ICMP echo request packet will go to the PCB.
Okay.
So once PCB is received, and it will do that round trip time, and it will check, and it will come back with the ICMP echo reply packet. In this echo reply packet, we will contain the type 0 code 0.
Mhm.
So
Okay.
this is the process behind this ping and the R.
Okay. That's a fantastic thing. Use this fancy keywords called if any frame received by switch, right? Use the
Okay, okay, sure,
keyword
sure.
called MAC lookup.
Frame. Oh,
The
Mac look.
frame
Okay.
and it will do MAC lookup. It means it will check
Mm,
the MAC address, right? Destination MAC address in the
mm, mm,
MAC
mm.
address table. And also
Ah,
you missed only one point, like it will learn the source MAC address also in MAC table, right?
yeah. Yes,
Yeah,
yes. It will learn the
it
source
will
MAC
learn.
address,
Yeah,
and it will store that
that's fine.
source MAC.
That's fine.
Mm,
Totally fine. Whatever you said is it's a fantastic. I didn't expect this from you. Really awesome. Okay.
thank
Now,
you.
now, coming to the DNS process, right? So
Okay.
just I'm typing www.tungabhadranetworks.com or .in my website. What
Mm,
exactly will happen at the back end? Can you please explain the process? Yeah.
okay, sure. Just consider a PC. First, we are going to go to the web, any browser, and we are going to search www.tungabhadra.com. As a human, we are able to understand this, but as a local mission, it will unable to understand this www.tungabhadra.com. So, for local mission understanding, it needs IP address. So, first, that local mission will check its local cache, that particular IP address is available or not in its local cache. If
Mm.
it is available in its local cache, it will establish a connection with that particular web application using port number 53 TCP connection. It will
What
establish a
is it use 53? Okay, I'll give you a
yes.
hint. I'll give you
Port,
a hint.
mm,
So if you type www.google.com, you will see
mm.
some thing, right? HTTPS or something.
Yeah, it will use a HTTPS
What is
and
the
it will
port number of
establish
what is the port number of HTTPS?
HTTPS port number. It will use 443 port number.
Then why 53 comes in the picture? Okay, it's a
Actually, in normal scenario.
if you need a bulk information, it will use 53.
Mm,
Okay,
mm,
yeah, whatever you said, right? It is correct. It will establish a connection with the server, but the port number
mm.
is 443, not 53.
Oh,
Yeah, now
okay, sure.
continue. Now continue. Yeah, please go ahead.
It will use the port number 443, and it will establish a connection with the server using TCP three-way handshake. If
Yeah.
it is available, that IP address is available in local cache. If in case that particular IP address is not available in its local cache, it will send a recursive query to the DNS resolver.
Okay.
So in DNS resolver also, it will check its local cache, the particular
No,
website
I
IP
need a
address.
I need a packet level
It
stuff.
will use the okay. It will use the UDP port number 53 here. So
Okay.
here
Yeah, go ahead.
is it
Yeah, it's correct only. Before going to transport layer field, explain me
okay.
layer 3 fields also. What is the destination IP, source IP
Okay,
here?
okay, okay, okay. The source IP is that PC
Mm,
IP,
very good.
and the destination IP, whatever you are going to search that a particular application, right? We are going to search www.tungabhadranetwork.com. We don't know that IP. For identifying that IP, we are using this DNS resolver. So at that time, it
Yeah.
will use the UDP packet, and it will use the port number 53.
Yeah,
Once
you forgot to tell
it will
IP. What is the destination IP?
IPv destination IP, we don't know the destination IP. That is a DNS resolver's
Yeah,
IP.
that is
Mm,
correct. It's a DNS
okay.
resolver IP. You already told
Uh,
it, but didn't mention. Yeah, please go
mm,
ahead, ma. Yeah.
okay. It's a DNS resolver IP. Then once DNS resolver reach this request, it will check its local cache that the
Mm,
particular website application IP is available or not inside its local cache. If it is available, the DNS resolver will generate a non-recursive
mm,
packet to the PC. If in case that particular IP is not available in DNS resolver cache, it will generate a recursive, I mean, iterate to query to the root server. We have 13 root servers.
yeah.
Here, that source IP is the DNS resolver's IP, and the destination IP is the root server IP.
Perfect.
So here, yeah. And here it will check that root server, it will not contain that author A2 server IP address, but
Hmm.
we have a 13 root servers and it will provide the top level domain server IP address.
Yeah.
So once it will generate that again that the DNS resolver will establish I mean iterate to request to that top level domain.
Okay.
Here that source IP is that DNS resolver IP, and that destination IP is the top level domain server IP.
Okay.
Here in top level domain server, that it will be like classified like a .com, .in, .org, .uk.
Yeah.
Based on that, we're able to identify a particular authoritative server IP address. So here also we are unable to get that our application IP, but the top level domain server will provide the authoritative server IP. So once we get that authoritative server IP address, then again DNS resolver will send that iterate to query. Iterate to query to that authoritative server. So here that source IP is the DNS resolver IP and the destination IP is the authoritative server IP. So here we are able that authoritative server will respond with that whatever we are asking, whatever you are searching for that our particular website, it will provide that particular IP address to our domain. DNS resolver. Once we got that IP address, that DNS resolver will respond to the PC in the form of uh, non-recursive
Yeah.
non-recursive type. It will generate that IP address. Once our PC will get that IP address, again it will establish the connection with that particular web application server using the
Okay.
port
So
number 443 and
yeah,
TCP.
finally you got the IP address of Tungabhadra network. So you said
Mm,
TCP three-way handshake process, right? Can you explain
yes,
what
yes.
is that?
Yeah, in TCP TCP three-way handshake process, first that TCP will send a sync packet to the server. Sync means at the time of generating that TCP header, we have that options like flags. Inside that we will at the time of sending the sync packet will be one. So at that time we are able to know we are generating the sync packet. So in the sync packet, why we are generating the sync packet means we need to establishing the connection with the server, right?
Yeah.
So for establishing the connection with the server, we are establishing using the sequence number. So for that server is replying back with a simplest act. Simplest act means whatever you are requesting. So for that I'm giving the acknowledgement. At the time of reply packet, we are able to see that like sin is equal to one and that act is equal to one means we are getting the acknowledgement from that server. So again we will get we will that PC will generate the acknowledgement. So we are getting the acknowledgement from that particular server. So at that time inside that packet we are able to see the act is equal to one. So
Okay.
this is the three-way
Who
handshake
who will give
between
acknowledgement?
that particular server.
Server
Why,
will give acknowledgement.
that application no,
So
this PC will
PC,
give
right?
that acknowledgement.
Yeah, you're
Yes.
saying correct only. Be cautious. Okay. Yeah. Yeah. The computer will give acknowledgement to the server. Then what will happen? The three-way handshake process is completed.
Three-way handshake will,
Now
yeah,
session
the
is
tunnel will be
established.
formed.
Yeah. Tunnel
Yes.
will form. Yeah. Then after that, some TLS handshake. That is necessary, not necessary now. Okay.
SSL.
Cool.
Okay, SSL
Yeah.
handshake.
Cool. Fine. Oh, that's a fantastic answer. Really well. And now I'm moving to the DHCP. So now
Okay.
my computer doesn't have any IP address and all. So what is DNSCP? We need DHCP, right? In that case, what is DHCP? How exactly it will assign the IP addresses to the computer? Can you please explain the process?
Yeah, sure, Ani.
Mm.
Why DHCP means for our local emissions we need a IP address. So
Yeah.
for automatically assignment, it will take a long process. It is a time-taking process. So for manual assignment, we are using the DHCP server. DHCP is
Correct your statement. You're mixing. Oppositely you're saying. Manually, it will take time, right?
sorry.
Okay.
Manually assigning it will take
Yeah.
time.
Yeah.
So
Yeah.
for that we are using DHCP for automatic assignment
Yeah.
of IP address, subnet mask, and DNS resolver. So at that time we will
Please go
configure
slow.
one.
Okay. You're saying everything is correct. So by like jet speed you're going, so you're jumping the things, but be really well, Amma. Just decrease your speed and everything will be all right. Yeah, please go ahead. Yeah.
Yeah. So first that DHCP
Voice
dynamic.
is maintain a high level. The speed,
Mm.
speed only. Okay,
Uh,
yeah, please go ahead. Yeah.
Dynamic host configuration protocol DHCP means,
Mm.
yeah, for assigning IP address automatically we are using DHCP.
Yeah.
So inside this DHCP we will follow the DORA process
Mm.
for assigning the IP address. The first one is the DORA. DORA is nothing but the discover. We are going to discover first. PC will generate the DORA. I mean
Mm.
DORA request,
Mhm.
like that's a discover, not a DORA
Discover.
discover,
Yeah.
discover to that particular DHCP.
Mm.
So for getting that particular IP address, we need to configure a DHCP pool with the IP address
Okay,
first.
so DHCP
Mm,
server is already configured here. Okay,
okay.
cool and all. So my
Mm,
client is here. Now tell
mm.
me. Yeah.
Now that the client will send a discover message to that DHCP server.
Mm.
So once discover message is sent to that particular server, the DHCP server will give that uh, offer, like
Okay.
it will offer particular IP
Yeah.
address to that
Before,
PC.
sorry to interrupt you.
Mm,
Before going to
mm,
offer, right? So
mm,
the
mm,
client will send a discover message. May I know
mm.
the which transport layer protocol it will use? DHCP.
DHCP it will use UDP.
What is the source port and destination port here?
Source port at the time of from PC side, that a source port is the 68, and from that its destination port is the 67 from the
Perfect.
PC side.
Perfect. Fine.
And
Now the
mm,
server receives this discover message,
mm.
and this again, sir, what server will do?
Server will give that offer. I'm going to providing this particular IP address to you. So it
Okay.
will be an offer message. So
Mm.
once that PC receives this offer message,
One
it
second
will
here.
mm,
It receives the offer, right? What are the
mm.
basic options you will see in offer message?
In offer message, I'm able to see the option 50. Option 50 is the client identifier, and option 51 is the
Option 50 is
no,
the
no,
client.
requested IP address. Option 50 is the
Who is the
requested
see?
IP.
It's a offer, right? It's offering means it is saying it's your IP. Then after there is a
Mm-mm.
some options. What is option one? Remember?
Option 1 is a subnet mask,
Very good. What is the
and
option six?
option 6 is the DNS domain name server IP.
Okay. What is the option three?
Option 3 is that router gate, subnet mask, gateway IP address,
Perfect.
router IP,
That's it.
router IP address.
And
Mm.
you DNS and subnet mask and IP, you told it, right? And there is a one thing,
Mm.
lease time. Which option
Yeah,
is it,
least.
lease time?
Uh, Sorry, least time. That
Lease time.
option,
Do you remember that
uh,
option? Lease time option.
uh, least time option is 51.
Yeah, yeah, 51.
51, I guess.
51 correct
Yeah,
only. Okay.
51 is the
Release up. Okay, now you receive the offer. Now what PC will do? Please go ahead.
PC will request whatever you are
Mm,
going to offering to that IP address, particular IP address. Please assign to me, and it will request to that our DHCP server.
okay.
Once it is request, based on that request, it will acknowledge whatever it's already offered, and it will assign that particular IP address, subnet mask, and that router IP to that PC.
Okay, perfect. Now it is assigned. So all these discover, offer, request, and
Mm.
acknowledge, right? These packets are
Mm.
all what kind of packets? Is it broadcast packets or it is unicast or what?
These all are no, no. These all are broadcast packets,
Mm,
because we don't know, right?
yeah,
That we are going to request which one. So those all are broadcast packets only.
yeah. Okay, perfect. That's fantastic. Okay.
Mm.
So RP is a which layer protocol,
RPC layer 2 protocol,
but it carries
but
the
it
layer 3, right?
yeah, but it will use that layer 3 payload by because going to use that particular IP address to identify the MAC address. So that's why it will carry that L3 layer
Payload,
3
payload.
payload. Yes.
Perfect, perfect. Fantastic answer. Okay, very nice. And next, okay. So what is the port number of SSH?
SSH port number is 22.
What is the port number of HTTP?
HTTP port number 80,
Telnet?
23.
Fantastic. Okay. Now move into routing. Okay, basics are
Okay.
perfect. Okay, let's move to routing. Which routing protocol you are familiar with?
I'm familiar with the OSPF and PGP.
Okay, fine. Let's go with OSPF. So,
Mm.
I'll just directly ask you the questions. Now you're good at packet level. Okay. So I'll just ask the questions. Just tell me, So how many
Yeah.
OSPF packets we have?
We have a five packets. The first one is the hello packet. Second one is the database description packet. The third one is the link state request, link state update, and link state acknowledgement.
Very nice. And if I configure OSPF between two routers, can you explain the states and adjacency process?
Yeah, actually, let's consider the two routers R1 and R2. In between that, we configure the OSPF. Actually, we have seven states in OSPF that neighbor discovering states. The first we are configure that OSPF right in between the first two routers in down state. Once we are configured, that will be moved to initialization state. In initialization state, that R1 will send that hello packet with the OSPF fields. So once that R2 receive these, it will check that all fields are matched or not with the R2 fields except that router ID. That
Yeah.
router ID should be unique.
Yeah.
So once these all fields are
What
matched
are the
with
all
that R,
fields other than router ID? Can you please tell me the fields if you remember, whatever you remember?
yeah, it's a version, router ID, area ID, and subnet mask. These all the fields. It
That's
should
it.
match with that R2 router fields also.
Remember any authentication thing?
Yeah, authentication type and authentication. Like
Yeah.
authentication thing, I'm not able
Yeah.
to get.
Authentication also there, right? OSPF
Yeah, yeah,
authentication.
yes, authentication also.
Authentication
Version
type
type and authentication type.
and data as well.
Yes,
Yeah.
data.
Yeah. These parameters, now it's matched. Now please go ahead.
Now, once it is matched with that R2,
Mhm.
then R2 will recognize R1 is its neighbor, and it will send another hello packet to R1. And in at the time of sending the hello packet, it will place the active neighbor field. Inside the active neighbor field, it will place the R1 router ID.
Okay.
So once that it will send that hello packet from the R2, that R1 it will be in initialization state, and it will waiting for that R1 route. I mean any hello packet. And before starting, I missed one point. It will go through with that unicast IP, that is a 224.0.0.5.
Is
It
that
is a,
unicast?
sorry, multicast.
Okay. Cool. Okay. So allow packets are exchanged through
Okay.
multicast IP. Okay.
Multicast IP. This is I mean this is for only OSPF groups only.
Okay.
So
Perfect.
once it is that hello packet is sent by the R2, so it is received, that R1 is received. Actually, it will wait for any hello packets is come from any other neighbors.
Mm,
So once it is received that hello packet from the R2, it will check that in hello packet that active neighbor field,
mm.
it will see its own router ID. Then it will recognize R2 is recognizing R1 as a neighbor.
Yeah.
So then this the whatever saying the same process will be happen in R2 side. It will look by
Yeah.
um, it will do like bi-directionally from the R2 side also.
Yeah.
Once this both will exchange this hello packet, it will move to two-way state. Once
Yeah.
it will move to two-way state, that both neighbors will discover. And in two-way state, after discovering that neighbors, it will elect the DR-BDR elections. Why DR-BDR elections means for avoiding the duplicate LSCs, we are going to elect the DR-BDR elections. Then after the packet will move to, I mean after it will move to that exstart state. In exstart state, that data synchronization process will start by exchanging the dbt packet.
Yeah.
Here, that in exstart state, the both routers will elect master and slave elections will happen by exchanging the type 1 lscs. So how it
Type
will
1 will exchange the type 1 elections immediately or after master slave?
after master slave only it will exchange the
How
type
they
1
will
LSC.
elect master slave? On what
uh,
basis?
Actually, it will elect based on the router ID. The
Okay.
highest router ID will be the master, and the lowest router ID is the slave. So,
Yes.
that highest router ID is the master, right? At that time, we will able to see inside that the packet MS bit is equal to 1,
Mm,
and in that slave packet MS is equal to 0. So,
perfect.
first that slave will start exchange. I mean, slave will start advertising. I mean, sending that
Correct. Correct. Yeah. You're
type
saying
1
correct.
LSCs.
Yeah.
Yeah, type 1 LSCs. Then after receiving type 1 LSCs from the slave, then again master will start sending that type 1 LSCs. So they both will exchange the type 1 LSCs. Then after the both will move to exchange state. Here the total type 1 LSS exchange will happen.
Mm-hmm.
So then after the both will move to loading state. In loading state, it will ask any missing router updates are there. So how it will based on that link state update, link state acknowledgement. I mean link state request, link state update, and link state acknowledgement. So based on that, DR will exchange that. Type 2 LSCs. We are
Okay.
already that DR elections
Yeah.
is happening to
Yeah.
two-way state. So based on that, we will exchange that missing routing updates. That is the network information. So here the type 2 LSCs will exchange. So after it
Only
will
type
after
2?
come
Only type 2?
type yeah type 2 LSCs.
Why not type 3 and type 4, type 5?
Actually, type 3, type 4, it's another scenario. First, it will inside the area. I'm telling.
Okay, okay.
Inside the
Got it. Totally got it. Yeah, please go ahead. Yeah.
Okay, inside the area, that particular area only, it is exchanging. If it is a other than other area, then we will able to know the type 3 LSEs.
Yes, yes.
So here it will exchange, and after it will move to full state. In full state, it will use that Discastra algorithm. Then it will elect the best path, and it will install that particular path to that routing table. This is the process behind that OSPF.
That's a fantastic answer. I can, whatever you're saying, it's resemblance of me, whatever I use the keywords, the scenarios. Very good, ma. First time I'm encountering, there's a person, what exactly I expected answer, right? Same thing I'm expecting from you. Of course, there are
Yeah.
small things are there to improvise, but that is not considered. It's a very good answer. Very nice. Okay. So what is type 5 LSA?
Type 5 LSA is nothing but the external LSA. Let's
Mm.
consider two autonomous systems. We
No need
configured
to
the
elaborate. I understood totally. You got it. Just tell me what is type 5 LSA. Simple.
type 5 type 5 LSA is an external LSA. If you want to reach any external prefixes, actually OSPF is a database link state database protocol, right?
Yeah,
If you
yeah,
want to understand any protocol, so through LSA only we are able to understand. So
correct.
for external prefixes, so we need that type 5 LSA. It will convert that external
Who
prefixes
will
into
generate type 5 LSA?
ASBR will generate that type
Perfect.
5 LSA.
Who will generate type 3 LSA?
ABR of that area.
Okay.
ABR will
So
generate the type 3 LSA.
what is type 3 LSA? What information it contains?
Type 3 LSA contain that summary of that type 1 and type 2 LSA. It contain the type 1 and type 2 LSA. So for reaching that another area routes, will use it will convert the type 1 type 2 LSA into type 3 LSA.
Now, who is ASBR and sorry, who will generate ASBR summary LSA, the type 4?
That ABR will generate that type 4 LSAs,
May I
that
know why?
ASBR somewhere LS. Because that for internal routes, that internal area routes, we don't know who is the ASBR. So for reaching that ASBR, first we need to reach that ABR router.
Mm.
So inside that LSA, it will contain that link state, I mean advertising router and the link state ID. That link state ID is the ABR router ID, and that advertising router ID is that this
AB,
particular
ABR,
ABR. Yes,
ABR
ABR.
router ID. Yeah, correct. That's correct.
ABR router ID.
That's fair enough. Okay. So coming to BGP, why we use BGP?
For external prefix, if you want to establish a routing protocols between the different autonomous systems, we will use this BGP.
Okay, perfect. So what is the BGP TCP port number?
BGP TCP port number, it will use 179.
Okay. So how many states we have in BGP? Just tell me the states. That's it.
Okay, in BGP we have a six state. The first one is the ideal state. Next one is the connect. Third one is the active. The next one is the open send BGP open send state. BGP open confirm, and the final one is the established state.
Perfect. So how many BGP messages we have?
We have a four BGP messages. The first one is the open message, keep alive, notification, and update.
Perfect. Okay. Now, how many attributes we have in BGP? What are the attributes?
We have well-known attributes. We have three attributes. Uh, peer IP, that is the
Yeah. What
neighbor
is?
IP.
Yeah. Peer IP we call what?
Neighbor, that is the neighbor IP.
It's called next hop, right?
Yeah, next hop.
Okay.
Next hop, and that AS path origin. These
Perfect.
three is the well-known
Well-known
attributes.
discretionary. Any?
Well-known discussion.
Just tell me one. If you want to
Well-known.
influence outbound traffic, we use that.
That local preference.
Perfect. Yeah,
Yeah.
local preference. Yeah, fair enough. Fair enough. Okay. Yeah. Do you know the BGP path selection process by any chance? BGP path.
Yes, I know. Yes,
Yeah.
yes, I
Can
know.
you please explain how it will elect the best path in BGP?
So first it will check that next hop value. First it will go with the next hop, then highest local preference,
Mm.
then shortest AS value, shortest origin, then smallest MED value,
Mm.
then EBGP peer, I mean EBGP
Route.
route
EBGP.
prefers
IBGP.
IBGP. Then next it will go to that oldest route.
Great, ma. Very good. So first is next stop reachability. It will not check next stop.
Next
You
one.
should say next stop
Okay.
reachability. Okay.
Reachability. Okay.
So you're good at BGP. So now coming to switching, what is STP? Why we need STP?
STP is a loop avoidance mechanism inside the switches. It's by default in switches by default it will be there.
Mm.
So we are using the STP like in any redundant environment like switch one, switch two, switch three is connected in redundant environment. At that time, STP will avoid the loops.
Okay. How
It will
exactly
block
avoid?
one port.
Okay. It will block one port. Okay. How it will choose blocking one port? What is the mechanism inside the STP?
Actually, first these three switches will start sending the BPDU frames. So
Okay.
by sending the BPDU frames, it will elect that root bridge. Root bridge, how it will elect? We have a bridge ID. Bridge ID is equal to priority plus MAC address. Priority we have a by default 32768. If you want to choose any particular switch ID, we are able to adjust that priority. Then it will go to lowest MAC address. So
Okay.
based on that, it will elect that root bridge.
Okay.
Then
So there
after
is a
it,
one thing. One more thing is there in bridge ID.
bridge
Priority is
ID
there. Very good.
plus.
Priority. MAC address is there. Priority plus one more field is there. What is that? VLAN ID, right? VLAN
Yeah,
number.
VLAN ID. By default, we have
Yeah,
VLAN
VLAN
ID.
one, right?
Yes. Mm-mm.
3768 plus one. That is a priority.
Yeah.
Yeah,
Okay.
perfect,
Okay. Sure.
perfect. So bridge ID based on the lower bridge ID, what it will elect?
Based on the lower bridge ID, it will elect the root bridge.
Perfect. Now
Then
root bridge is elected. So what is the next process?
then
Yeah, yeah.
then it will elect that root port. How it will elect the root port means based on the lowest interface cost. We
Okay.
have so many interfaces cost like for ethernet we have a 100 and fast ethernet we have a 19 and gigabit we have a 4 and 10G we have a 1. So based on the lowest interface cost it will elect that root port.
Mm.
Then after it will comes to the blocking port, that it will comes again that bridge ID. What is the highest bridge ID? Then it will elect that as port as a blocking port and it will block that port.
Highest one blocking the port. Fantastic. And now, what is the difference between STP and RSTP?
The main difference is the convergence times and the states. In STP, we have the convergence time is the 50 second, and in RSTP, the convergence time is the 15 seconds. In STP, we are able to see the four states from forward, I mean, from blocking to forward. But in RSTP, we are able to see only two states.
Okay.
Uh,
What are those?
in STP, the first one is the blocking, listening, learning, and that forwarding. And
Perfect.
coming to the RSTP, we have only learning and forwarding state we are able to see.
Okay. Fantastic. And do you know why we use BPDU God?
Yeah, for we are using the BPD guard. Like if you are enabling any edge ports with the port fast features, at that time, by mistakenly, any field engineer, any other our engineer is trying to connect any L2 switches. So at that time, the BPDU frames will come, right? So if upon seeing that BPDU frames, we are enabling that BPDU code here. So at that time, that port will be go to error disabled state and.
Mm.
Uh, yeah, for going it will that port will be in a disabled state and it will go to a red disabled state
Why,
and
why, why, why we are doing this generally?
why because if you're going to just consider a scenario like one switch is connected that edge port is connected to that any server like any DHCP server, right?
Mm.
So it's a layer 3 devices, it will not generate any kind of BPDU frames, so will not get any loops from that server. So at that time no need of this convergence time. So in networking each and every second it will be we need to use, right? So for that, for immediate forwarding we will create that port fast.
Mm.
So at the time, by mistakenly, any field engineer trying to connect any L2, like L2 switch, any
On this port.
mean, any
Okay.
yeah, on this port. So at that time, the BPDU frames will try to come, right? So
Yeah,
at the time of
what will happen if I by mistake BPD frames came here? Then what will happen?
actually, we are not, configured any BPDU got that loops will occur
Okay,
at the
that is
time of
what I'm asking.
connecting.
The loop will occur. That is the
Okay.
answer. Okay, I'm expecting. Nice.
Mm.
And the final question I'm going to ask is VRRP. Do you know what is
Okay.
VRRP?
Yes, I know VRRP.
Can you please explain what is VRRP?
Yeah, VRRP, it's a virtual router redundancy protocol for achieving a high level redundancy. I
Mm-hmm.
mean, virtual level redundancy. We are using this VRRP. Like in our enterprise environment, we have two routers, like in each side, right? We're using that both as in redundant environment. So for both routers, we are unable to give the IP address, same IP address. If you are going to give any same IP address, that VHSR will calculate and duplicate address, IP address
Correct.
will calculate.
Yeah.
But in PCs also, we are unable to give that two IPs as a
Yeah, single
gateway,
gateway. Yeah, correct. That's correct.
single gateway. So at that time, what we are going to do, right? We are creating the VRRP group. It's a virtual group. So
Mm-hmm.
at that time, based on the priority, we are able to give same IP address to the PC. So
Mm-hmm.
based on the priority, that the PC will able to identify that gateway. So
Mm-hmm.
in case of any if in case of any hardware failovers, if we just consider two routers, router 1 and router 2, we giving the priority for the router 1. If in case any hardware failures, we will not unexpectedly it will happen, right? At that time, that PC1 will select that another, we have another redundant router,
Router.
right? It will
Yeah.
select that, yeah, it will select that gateway.
So VRRP packets will exchange through how they will exchange VRRP announcements.
Actually, it will announce every second. It will announce like through multicast. There is a multicast
What is
IP.
IP? Yeah.
IP address 224.0.0.18 is the VRRP
Perfect. Perfect.
multicast IP address.
So you said priority, right? If I configure highest priority on one router, what will happen?
That PC will elect that particular router as the first priority,
So what we
highest
call
router
router,
priority.
what is the state it is like? What state you will see? If I con router one, router two is there.
Master, yeah, it will be master. It will
Yeah.
elect as master. Okay,
Master, another one is backup. You must say that. Yeah.
backup.
Yeah,
Oh.
that's a fantastic. Okay. So in every aspect, you're fantastic, ma. I really proud about you. Seriously, proud of you. And one final interview question they will ask you during main, right? What kind of
Mm.
real issues you face so far? Have you worked any issue recently? The critical issue, the P1 or P2 critical issue, where you have contributed so much and resolved that issue. Do you have such kind of situation during your experience?
Yeah, yes, have that kind of P1.
Mm,
Like we are configured that port first, and we configure the port first and BPDU card. Actually, for that connecting the L3, it's like CC cameras. For CC cameras, we are configured that BPDU got and a port first. At that time, that field engineer, that particular, there is a separate team. So there, uh, unfortunately, they're connected that plug and play switch. Like it's we have a switches, two types of switches, right? So
yeah.
there are. Unfortunately, they connected the switch. At that time, that BPDU frames is generated. So we already created that BPDU card, right? So it goes to that error disable state.
Mm,
So that entire protocols are stopped. So at that time we checked at the back that the next other hand there that didn't configure any BPDU filter. So
mm,
if we are configured any BPDU filter inside that switch, it will not send and it will not receive any BPDU frames.
correct.
So we don't have any issues. So
Okay.
at that time, what we did, like we entered that port, a particular port, and whatever you created that BPDU card, right? So we disable that BPDU card. The services is restored. Then once they're created that BPDU filter inside that their side switch, then again we are enable that. We configure that BPDU
Mm.
got inside our switch. This is the scenario. Actually, this
So
is the
we
thing.
means you did or your team did?
Actually, this is the teamwork. I'm the one of the part in that
Okay, okay.
scenario.
Got it, got it. So the thing is how you restore that link. It went to error disabled state, right? So
Bounce the,
yeah,
yeah,
bounce, bounce.
shut down and
Yeah,
unshut and shut.
perfect. I'm so happy for your interview. Okay. So I'm telling you, I have
mm,
taken 10 to 15 years of experience candidate interview recently in my organization. They're
mm,
not good at basics, but this is the best interview with the candidate. The only suggestion I can give you is go slow and use the right keywords. You are already using the right keywords, but just flipping it between them. Just
mm,
go slowly and recall the
mm,
right words and
mm,
be cautious what you're saying. Okay.
mm,
Now
mm,
you're so much cautious when I was correcting you. And
mm,
yeah, all good, ma. Fantastic.
mm.
I really would like to refer you in other product-based companies. Definitely, I'll do
Thank
that after
you.
right. If anyone sees this interview, right, definitely they will. I will right away. I'm going to put this interview in YouTube. People who saw this, right, they can
Mm,
seriously, seriously, I'm saying the way you answer it, everyone should learn from you. Same way.
mm.
Okay. So if you give permission, I'll upload it. Or else, no. But this is really, really helpful to others. You
Mm.
just tell me. Okay. Okay, na? So how can I proceed further? Do you need time to think?
Yes, Sunny, I need to think.
Yeah. Think it and let me know if it is good. And
Mm,
if it is good to upload, then I'll do
mm,
that. Or else
mm,
I'll put in internal, at least private mode if you don't
mm.
want, because you know
Yeah,
what? You know what? This is really, really fantastic interview. Okay. Thank you.
yeah.
And all the very best. And I'll get back to you. Okay.
Okay,
With
okay.
reference.
Thank you.
Okay. Thank you, Ma. Have
Okay.
a nice day.
Thank,
See you.
thank you. Okay.